Pascal's triangle. Now this video will be me talking about how I was taught Pascal's triangle and binomial theorem and not about what Pascal's triangle and binomial theorem is. But to try and make you understand, I'll give you a quick summary for you to kind of understand or to remember if you forgot. I'm not a teacher though, so I won't really be good at the vocabulary stuff. So Pascal's triangle is a triangle to find the coefficients of a binomial of a plus b to the power of n, where n is equal to the row of Pascal's triangle. For example, if n equals 3, then you look at the third row and those are your coefficients. A plus b to the power of 3 is equal to 1a cubed plus 3a squared b plus 3a b squared plus 1b cubed. Now a and b's exponent's work is first. A's exponent equals n, and as it continues, you subtract 1 from n while adding 1 for the exponent of b until b's exponent equals n. Hopefully you got that. Now, notice how the exponents of a and b added together equals n, even when it is a cubed. There is still b, but b's exponent is just 0. When any number's exponent is 0, it will always equal 1, of course. Back to Pascal's triangle. How you solve for the next row is the two numbers from the row above added together will equal the row below it. For example, in row 3, you have 3 and 3. 3 plus 3 is 6, and 6 is the number in the fourth row. Summary over. Now, when I was taught this, the question was, what do you do when you have to solve for a row way lower, like row 15? What you do, instead of just going through all of the rows, which will waste time, is use binomial theorem. Now, binomial theorem, you have NCR. N, of course, equals what row slash the exponent of the binomial. R is pretty much just the exponent of b. Now, it becomes the formula NC0 a to the power of n b to the power of 0 plus NC1 a to the power of n minus 1 b to the power of 1 plus etc. all the way until n cn a to the power of n, a to the power of 0, b to the power of n. Now finding the exponents of a and b is the easy part. You know that a decreases while b increases until b equals n. B's exponent is equal to n. Now, what I was taught was NCR is what the coefficients is equals, right? And to find that, you put it in a calculator. You put in something like 5C3 in a calculator, and then boom, it equals 10. Now, let me tell you what was going through my mind, alright? There must be a way to find the row without a calculator. It's algebra. Like, dude, it's not trigonometry with sine, cosine, and tangent. Like, dude, I looked at Pascal's triangle, right? Trying to look for patterns and stuff. Looking at how the outside layer was always 1, the second to last layer is always increasing up by 1 every time. And this is what I came up with on how to find what the numbers were for a row. Alright, so let's start with some information just to make this video a little bit longer. So a row will have n plus 1 numbers. If we're talking about like row 10, it will have 11 numbers, alright? Now if n is even, there will be one highest number. If n is odd, there will be two highest numbers. Lastly, the first half of the numbers will be reflected to tell the second half numbers. Alright, let's use n equals 9 to show what I was thinking during this time. First number will equal 1, always. Second number will equal what n equals. Alright, so even though it took way longer to try out, to save time, I'm going to add that to get from 1 to 9, you have to multiply 9. Now we are solving for the pattern. So to get from 9 to 36, you need to multiply 9 times 4. Now to get to the fourth number from 36 to 84, you have to multiply 2, 1 over 3. Now to get to the fifth number, and technically the last number because this is pretty much mirrored to the second half, to get from 126 from 84, you multiply 3 over 2 times 84. Now remember, this is like over time and stuff, it didn't happen this quick, but then I thought usually putting them into improper fractions helps find a pattern such as the numerator getting rooted or something, you know? So then I put them into improper fractions. Alright, so the pattern then became 9 over 1, 4 over 1, 7 over 3, and 3 over 2. Now look at this, alright? You multiply 2 over 2 times 4 over 1 and 2 over 2 times 3 over 2. It became 9 over 1, 8 over 2, 7 over 3, 6 over 4. The multiple starts with the numerator equal to n, right? And then the denominator starting at 1. As it continues, the numerator decreases by 1, and then the denominator increases by 1. To find the sixth number for when n equals 9, fifth number is 126, right? 6 over 4 becomes 5 over 5. 5 over 5 times 126 equals 126. Look, I just found out the sixth number for when n equals 9. Then you continue, right? It's literally Pascal's triangle all over again when solving for a row, although this time you only need to know half of the row because the other half is technically mirrored, you know. Now, you know, I'm feeling like a genius. I am so smart. But thing is, here's a problem. If it's this easy, why did the teacher teach me how to find a row this way? Like, dude, I know people know about this method. I am not this smart. Dude, mathematics are not this unintelligent. You literally made me find out this all by myself, even though it's probably already in the record of how to find a row. Instead, I have to rely on a calculator to find NCR, to find the coefficient. Now, I did this without Googling, right? I just used my big brain. I just looked at Pascal's triangle. I looked at patterns. Took me like 30 minutes of actually trying to find patterns. You know, took me a day of thinking about it. Now, when I searched on Google, I found out what NCR's formula is. So NCR, right, equals n over r, which equals n factorial over r factorial times n minus r factorial. Luckily, I did kinda know what the exclamation mark meant because a guy named Rocket on Discord partially showed me it before. So with factorial, you are pretty much multiplying all decreasing numbers of the number. Like for the factorial of 4 is 4 times 3 times 2 times 1, and the factorial of 50 is 50 times 49 times 48 times 47 times 46, and then all the way until 1. Now we know what NCR equals, but here is the main problem, alright? This is why I made this video. Why would you give me a formula? Binomial formula, if you didn't define how to solve for all parts. I hope this was only for how I was taught, because wait, actually, hopefully it was how everyone was taught because it creates more relativity. But anyways, you gave me a formula to use instead of Pascal's triangle, saying it will take a long time to solve for a lower row. But to find out for the number that Pascal's triangle states, you have to use a calculator to solve for it. Yeah, it might be quicker than using Pascal's triangle, but formulas are supposed to be used to help humans solve the problem by themselves. Dude, by using a calculator, you're just telling me use the calculator for the whole entire equation. Now, what's a plus b to the power of 7? Oh, I just found it out. A to the power of 7 plus 7a to the power of 6, b plus 21a to the power of 5 plus b squared, blah blah blah. All the way until b to the power of 7. You know what I did? I used the calculator. I used Mathway. That's how intelligent I am. Don't give me a formula without defining how to solve for all parts without technology. Why are you forcing me to wait until, like, I'm pretty sure, like, the class is about probability of statistics? Just find what NCR equals and not just tell me now. Those are rhetorical questions, don't answer them. Anyway, that's overall, you know, like 30 minutes of my day wasted. A whole entire day of my thinking time wasted too. I would have rather been forced to stay in class, you know, learn about that. Looking back, you know, knowing that I was forced to do that class, and it will probably took longer than 30 minutes though. So that's really all for this video. If you enjoy my videos, you can subscribe, turn on those notifications to know when I upload, which is when I'm in the mood. Um, you know, you can like too, of course. Have a good day, and goodbye.